Hello everyone, in this opportunity we're going to explain what's the p-value and how to interpret it correctly. So first of all, before starting to define the p-value, we have to set up two important definitions. One is the definition of alternative hypothesis, and the other one is the definition of null hypothesis. The alternative hypothesis is just what my study wants to demonstrate. For example, I can say that my alternative hypothesis is that there are differences between drug A and drug B. This means that one drug is better than the other. That will be an alternative hypothesis. And my null hypothesis is just the opposite of my alternative hypothesis. After we have set up these two concepts, we can proceed to explain the p-value. Another important aspect is that you can just have either one or the other. You cannot have two hypotheses at the same time. If you perform a study and the study wants the alternative hypothesis, this means that you're rejecting the null hypothesis. So now we can proceed to define the p-value. First of all, I'm gonna draw a 2x2 table in which we are going to add our study here and the reality here. For example, you perform a study and the study says that there are differences between drug A and drug B. This will be that my alternative hypothesis is winning. This means that there are differences between drug A and drug B, right? This is what my study is saying. But if in the reality that's actually true, this means that there are differences between drug A and drug B. This means that my study is detecting the truth. This is called statistical power. Normally, we're allowed to tolerate 80% of a statistical power, and that's a standard value that's normally fixed. There is another scenario in which our study can say that there are differences, but in the reality, the truth is that both drugs are equal. So this means that our study is detecting something that's not true. This is called the alpha error, or also called type 1 error. This type 1 error, normally we are allowed to tolerate a 5% type 1 error, and this means a 5% type 1 error means a 0.05 value. This value is what is defined as the p-value. That is the probability. The p-value is the probability of committing a type 1 error. This means that our study is detecting something that's not true, and this is a really severe error. That's why we establish a really low margin of 5%. This value is also fixed in most of the studies. There's another scenario in which our study says that both drugs are equal. This means that we are rejecting the alternative hypothesis, and the null hypothesis is winning. in this scenario in our study. But in the reality, so we say that our study says that the null hypothesis is winning, right? But in the reality, the alternative hypothesis is the true. This is called a type 2 error, or beta error. Normally we're allowed to tolerate a 20% type 2 error because this mistake is not as severe as this mistake. That's why the margin is much broader for type 2 errors. And there is another scenario in which our study says that both drugs are equal, but that's actually the true. So this will be called 1 minus alpha. As you see, when we sum up everything, it gives 100%. In this scenario as well, 5% plus 1 minus alpha, it gives 100%. So the next step, as we know what's actually the p-value, the next step is to define what's the difference between the alpha value and the p-value. The alpha value is a margin that we establish a priori, that it will be a 5% margin. But the p-value is actually the result you find in your study. That it could be, for example, it will be 0.5, and the p-value, the result that you find in your study, that it could be 0.2, right? So there are actually differences between the p-value and the alpha value. Normally, if you have a p-value that's higher than 0.05, you are able to reject the alternative hypothesis, because there is an extremely high probability of having a one-type error. But if your p-value is less than 0.05, you can accept your alternative hypothesis. In this scenario, reject the alternative. And that will be pretty much all.